This episode of the Ask Joe Powder Powdcast is brought to you by Gema. Synchronized monitoring and control of your entire automated process is the core of Gema's Magic Control 4.0 data management systems, with options like line management, offering deeper insight into productivity and consumption, or energy management, allowing you to monitor and save both energy and air consumption, or batch management, offering tracking of powder used to coat production batches. Gema provides the very best in technology and connectivity for smarter factory automation. To learn more about Gema's Magic Control 4.0 data management systems, visit CompleteItWithGema.com. When you want to know that everything is covered, complete it with Gema.
Hey, powder coating fans. Welcome to the 14th episode of the Ask Joe Powder Powdcast. I'm your host, Joe Powder, and with me is my sidekick and partner in crime, Nathan. He's our powder coating formulator dude. Today we're doing things a little differently. Instead of Joe Powder answering your questions, we're going to flip it around and ask someone from the industry about some of the cool stuff that they're doing. Today's interview is with Chris Redding from IFS Coatings. They're an innovative powder coating manufacturer headquartered in Gainesville, Texas. Recently, IFS has developed some breakthrough powder technology for the wood market. So, we're going to be asking Chris Redding, what's up? Take it away, Nathan.
So yeah, I mean, basically, I think we explained to you on the call that we had. Like, our idea here is to, we want to talk to a bunch of people, different people from different parts of the industry, and hopefully make it interesting for anyone that listens to it. So I don't want it to be just like pure like commercial, like this is presenting this one product, but obviously you guys have interesting technology, and that's definitely something we'll talk about. So
you can just kind of cover the full gamut, really. I mean, the message for me is that we're ready finally as an industry.
Yeah.
And we really weren't when we thought we were. So I mean, we spent a lot of years, if you remember the 90s, with the acrylated polyesters that were launched by UCB, and DSM did a urethane system with polyester, and actually had a plastic component to it that gave it the flexibility it needed. So that was nice. It was still UV and very expensive to get into.
Yeah.
And limited, right? Line of sight, and you couldn't really do multiple layers, and film thickness was limited, and some colors really don't like to absorb UV. And so it had some fallback. So it's still kicking around. It found a home in some horizontal lines, but I think really the culmination, though, of on the chemistry now with the system that cures it, in 3 minutes at 130C, 265F. And is flexible after cure. We really came up with something, and that part couldn't really happen until the oven technology came along.
Right. Yeah. Man, we just covering a lot of ground there. Let's take a step back. So you're talking about the previous kind of approaches to doing, low temperature. You got the UV, which, obviously that's line of sight.
Right.
You can do two-dimensional parts,
sure.
Pretty much.
Yeah.
But, it has...
But it found a home, right?
Very low temperature, so you can do it on some low temperature sort of substrates. But then the other sort of thermoset technologies, why did you say those didn't really take off?
Well, you mean like the catalyzed hybrids and Morton Lamineer years ago. Basically that process incorporates like 15 minutes of preheat, basically to cook all the moisture out.
Right.
And so and then about 10 minutes of cure, all at around 290 to 300 F. Well, this really limited the substrates you could use to some pretty expensive MDF. And those systems got better. We still offer them. But, to get, say, the test like the Kitchen Cabinet Manufacturers Association test.
Yeah,
right?
yeah.
Requires
a lot of food products, I understand, right? Like,
well, you just have to accommodate. Wood doesn't behave after it's painted.
Right.
It likes to swell and shrink with absorption and loss of moisture over time. And so you needed to make the catalyzed hybrid system pass that, to my knowledge, you got to do 2 coats.
Okay.
So now we're really putting the board through heck, right?
Mm-hmm.
But with the polyester and urethane system, with a vinyl ether component, actually, you get a very flexible finish that blows that test out of the water.
Right.
But I think the chemistry wouldn't be anything, though, if it wasn't for the oven, the catalytic IR oven. Right.
Right. So, yeah, how important is that? You think that, is that an absolute necessity to have the gas catalytic as you?
Electric works as well. So if you look, this is from a spectrophotometry to see where materials absorb energy. And the gas or the catalytic IR is actually emitting the wavelength from the 3 to 4 micron range, which happens to be exactly where organic materials like to absorb energy. Right. So if you look at a PowdTech data sheet, it generally will say something like cure schedule is 10 minutes at 400 F.
Right.
And they'll say metal temperature. But with this oven technology, I don't care what the metal temperature is or the substrate temperature, because the paint itself absorbs the energy rather than waiting on the metal to heat it up. Does that make sense?
Yeah. So you're matching the output of the oven to the absorption range of the actual organic material.
Yeah, so it changes everything, right? So now this moisture content isn't my enemy. If I have too much, I can still get out. Gas can have too little, I have electrostatic problems. But if I'm in, say, that 5 to 7% range, right, moisture, I can kind of leave it in the board and still cure the paint, right? And so I can also use pretty darn standard MDF, stuff that's like 48 pounds a cubic foot of density, which is the grade of MDF that the big factories are using, right?
Right. So, okay. So it's pretty simple to put it on MDF, right? Like, it's pretty straightforward, you say?
Yeah, I mean, there's a couple nuances with the process. So it's going to look a lot like metal. We can talk about how it's different than metal, but for one thing, the pre-treatment is sanding, right? We still have to sand the wood.
Yeah, of course.
So we're not dealing with pre-treatment chemicals, this type of thing. If you're talking about a absolutely non-conductive substrate, it'll do like iodine solutions, things like that, to make it electrostatically conductive.
Mm-hmm.
But on loading, it's just like metal. We can very densely load a line. So for very efficient and very good line density. Preheat with what we call the FFT technology, which is the polyester and urethane system.
Okay.
We'll preheat to get it to a good hot summer day in Texas. The reason for that preheating is really to equalize the distribution of moisture through the board. It takes about a minute. Okay. Application side is pretty much like it is with metal. There's some nuances, but it's anybody that's done metal would know how to do it with a short lesson. And then curing, we're about 4 minutes in the cure oven, about a minute of ramp up, and then the cross-linking occurs when we hit the 275. It's kind of a cool thing with this technology too, that the flow and cure mechanisms are separated, much like a block urethane. It's not the same dynamic at all, but it's a reference. So we can actually flow out very nicely before we start cross-linking. And that addresses the smoothness issue where we've always been there. So in a process that takes about 7 to 10 minutes, we fully coated a cabinet door, for instance, and done a beautiful job on it and given it a coating that's actually far better performance than the incumbent technologies that are out there. Excuse me.
Right. And so would you say that's the most common application for it? Would be like the kitchen cabinets or furniture that's generally made out of MDF?
Yeah, you still see, I mean, you see it there in Europe where this technology was first launched. And, with my previous employer, it really took off in cabinets.
Yeah.
Probably the largest is a coater that does bathroom vanities and bathroom vanities and day beds to the tune of about 10,000 units a day.
Okay.
So it's really taken off. So yeah, Europe is really embraced it. There's probably a good dozen or more cabinet shops that are doing doors.
Mm-hmm.
And then of course the really big guy, about, like I said, 10,000 units a day for a pretty well-known furniture manufacturer. So it's done quite well. We're in baby steps here.
Mm-hmm.
We've seen a fella doing fiberglass gun stocks.
Oh yeah.
Worked very nicely on that. But I think we'll probably follow Europe on the cabinet fronts as your first big launch, because if you've ever seen current operations with liquid paint,
mm-hmm.
They're going to sand that substrate just like we will, or pre-treat, right? Then apply a primer, and they're going to run that through an oven for about 10 minutes to dry it, and then they're going to sand it again, and then they apply a lacquer coat for the first opaque coat, right? And then depending on the color, they might do up to 4 layers of that lacquer coat to get opacity. Right.
That's crazy, yeah.
And sanding in between each and running through the ovens each time. And then a sealer and then sanding.
Yeah.
And then a clear coat. And now it's finally done. Well, we took that process and said, now it's sand it, run it through a 7-minute, about
7 minutes, yeah.
And cool it off and package it.
So it sounds like a no-brainer. Like, what do you think the reticence is, or like why are people slow to adapt?
Well, they're missing. I think we talked about a couple of the missing pieces. We talked about the catalytic IR oven, mm-hmm. solving a big problem for us. We talked about the coating chemistry, solving the big problem for us, right? Another aspect was on the application side. Look, this stuff wants to picture frame,
right?
Right, and some things like the counter electrode. Mm-hmm. This has really helped, or in the case of a batch system or robber bar. But the missing piece now really is coders, contract coders that, since I joined IFS a little over a year ago, my whole focus has been, well, one, on our process and technical development, but really on developing the market to say, when I go to OEMs and they get all excited, right? I flew one a couple of years ago all the way to Europe to a line in Slovakia to see it, and they were amazed, right? Yeah. And then we came back with powder primer doors and ran those on his line, mm-hmm. in the U.S. big line, and they got that opacity in one coat, right, rather than 4, and they were like, good to go, man. Who's a coater that we can send this to?
Right.
I said, well, we don't have one.
Yeah.
I think you just visited him in Slovakia, right? He says, well, come back to us when you got some coaters. So I've been careful not to get out and do what I enjoy doing the most and probably I'm best at, which is getting OEMs excited about this until I have some coaters. Now, we've got one started, and we've got several that are quite interested in making the investment. But, for me personally, I wouldn't go in the business without the catalytic oven. Be honest with you. I mean, there are those that have done it and done it successfully, but when you see how much easier it is with that oven, I sound like an oven salesman more than a powder salesman right now.
They're all pieces that have to go together, though.
Yeah. Well, and that's why I reached out and I've got a list of folks that have been committed to powder on MDF, powder on wood for the long haul. I should stop saying MDF because we're well beyond that now. We can do stain alternatives on hardwoods. We can do fiberglass. We could do, of course, MDF, HDF, and all that. There's actually a coater in New Zealand, a company in New Zealand that's powder coating drywall.
Okay.
Prefab house. So
yeah.
The more we look, the bigger the market is. But so there's a collaboration between those value chain players on the equipment side, on the powder side, on the raw material side. Everybody has to really work together. None of us can do it our own. Yeah. And I think that's something that we had to learn as an industry as well.
Right.
And then just like on the metal coating side, if you've been around powder as long as I have, there was a time when conversions of liquid to powder and metal were just going on so quickly and so rapidly because of that powerful value proposition. But it didn't happen without contract coaters.
Yeah.
And that's the final piece. I'm not going to say it's the missing piece anymore because we do have early adopters that are engaging, but that's the critical part.
But yeah, just like going from liquid to powder, it's not a drop in. You can't just like necessarily convert a line. It's going to be a lot of moving pieces. If
you look at the large OEM wood makers, wood product manufacturers, you go into their factory, it's busy.
Yeah.
Right? And their square footage is filled up. So you can't say, okay, turn that off, decommission that, slide powder in.
Right.
So you gotta have a jobber.
Yeah.
You gotta have a jobber. Okay. And it's and the folks that are gonna buy into this early, you'll see a repeat of what we saw in Europe, where it just really starts taking off.
Yeah, once you do the math, it's just like it seems like it should be pretty obvious. But yeah, the math involves really big numbers to start with.
But it's pretty simple though in a lot of ways. I mean, well, you mentioned the math. So this is online. It's a company in I believe it's North Carolina that they sell cabinet fronts.
Mm-hmm.
And if you want to buy an MDF flat panel door like the one pictured here, they want $15 a square foot for it.
Okay.
If you want it painted, they want $27. I'm sorry, this is thermofoil, this example. If you want thermofoil, they want another $12.
Mm-hmm.
Okay. See, if you look at the MDF, which is for painted now, this checker door, they want $14 a square foot. Right? If you want it primed, they want another $11.
Mm-hmm.
If you want it fully painted, they want another $20
okay.
per square foot.
Yeah, geez.
Right? So they're charging more for the finishing than they are for the door.
Right. Because of all those coats you're talking about.
Yeah, because it is a labor-intensive paint. They have to deal with solvent, the regulations surrounding solvents and VOC emissions. If you walk in, the place stinks. I forgot how bad paint smelled.
Right. Yes.
Right. There's diseases that painters are getting. They call it painter's disease, where over time being exposed to those solvents, are causing problems with brains and everything else. And you say, okay, well, I've got something with 0 VOCs. It's going to go through your line one time. The finish isn't going to crack or peel ever. And it's going to cost you a whole lot less money.
And you can reclaim it and...
Absolutely.
Yeah, all those old, going from liquid to powder arguments, I mean, they all still stand today.
Yeah, absolutely.
Even when we bring new substrates into it.
Yeah, so it really is a no-brainer, right?
Yeah. All right, so you were talking there about, beyond MDF. So I'm curious about how you would do like wood, hardwoods, natural woods, because typically the problem with those is, you hit that 100C, and especially once you go over that, and the moisture comes out, and they're not as consistent across the surface as MDF is. Manufactured boards in general are going to be kind of homogeneous. But yeah, how does this work on natural wood?
You'd be surprised. Actually, with like maple and oak, we found that even sometimes it's better off to not even do the preheat part, because the moisture distribution is for some reason a lot more equal in a hardwood than it is in an engineered wood.
Okay.
I guess maybe it doesn't. I'm theorizing here that maybe it doesn't travel as rapidly through the board. But
Okay.
when we're only at that surface temperature of 260 for 3 minutes, it's a pretty gentle process. And the hardwoods actually they coat very nicely. Yeah. The only thing where we really haven't been able to figure it out too well is needle woods. I think we're going to need a lower temperature even more.
Right. They're even more sensitive to, I guess, the outgassing, the pinholing, the
yeah
sort of defects that you get from that.
Absolutely. But another important part is really the acclimation. So this is actually from the Wood Handbook, it's called. But really, to get the moisture content, it seems like 5 to 7% is kind of the sweet spot, right? Some chemistries can bear a little more and are more forgiving, but really, all I have to do that is to keep the material in a constant relative humidity, sort of in this ballpark, depending on the temperature. And what will happen is, with enough area of the surface area of the wood exposed, really, a half-inch thick board will be at the target moisture content pretty much overnight.
Okay.
And and really maintaining a relative humidity is it sounds scary to somebody who's never had to deal with it, but it's super easy and super cheap. In fact, in Europe, universally, almost these guys started out with a room that they would control the humidity in, so that the boards would acclimate. And I finally just figured out it's so inexpensive to do. I mean, that they just do their whole facility.
Well, and also, I mean, this being a low temperature curing powder, like a lot of times it's recommended to keep the humidity and the temperature pretty controlled with storing those as well. Is that an issue with this stuff?
Yeah, I mean, it's the same rules as any other powder with in terms of exposure to humidity. You want to close your bag and all that and not let it absorb and get clumpy, especially if you're in a high humidity environment. But one of the hurdles I guess I failed to mention was storage stability, and now actually with the system I keep referring to, we're storage stable at ADF.
Oh, really?
Yeah. So, and I think we've gone up to like 6 or 8 months, and the stuff still flows beautifully and no problems. What am I going to do in the summer months shipping out of Texas? That's a question I got to answer.
Right.
But I think we have some solutions there in terms of packaging solutions and all that. And there's always a reefer truck, but those are darn expensive. So we're getting creative to come up with something there.
Okay.
But that aspect's pretty good. Just kind of look at some other stuff I might not share with you. This was on the application side, so I wanted to cover. So this is that uniform deposition is especially a challenge with nonmetals, with fatty edges and the like. If we look at something like, especially for a stain alternative where we'll tint a clear so that you can stain a hardwood with powder paint or create the appearance of a stain because we're not soaking into and actually staining it. That uniform deposition is absolutely critical because you'll see shadowing if you don't have it, right?
Oh, yeah, because just the thickness is going to make things look different.
Absolutely.
Spots.
And then, so one solution is a rubber bar. If we're talking about a batch operation, we can ground a piece of metal, put it behind the target, and that grounded piece of metal is going to draw that powdered it rather than wrapping. Nice, cheap way to do it. If you've got a continuous process, the dynamic counter electrode, this is a device that's going to create a positive ion field behind the part. The powder's charged negatively going to the neutral substrate, right? But when that powder, negatively charged powder, hits that positive field, it just loses its charge and falls away.
It just falls to the ground.
Yeah, and what's really cool with this device is that you can. I've seen it actually where it's so precise that it looks like you taped off half of that edge, right? So there's a line. That's how precise it is. Yeah.
And
So
is that something that can be adjusted then? Like you could.
it sure can. Yeah, in and out. So picture, if you put a hole in the backside of your booth and put a tribo gun in, right? That's essentially what it is. It's a little, it's a little more engineering than that, obviously, but they can take that bar and decide exactly where they want that ion field to be. So it's very precise, and essentially the technology is kind of like a tribo, and so very affordable. It's about what you'd pay for a tribo gun.
And then is that stuff commonly available, or I mean, as far as the application equipment goes?
Yeah, there's a couple of the spray equipment guys that do that. Anybody wants a referral to somebody, just you can reach out to me.
Yeah, or listen to the ad break.
Yeah,
we have a sponsor that's a spray equipment.
Are you looking for a solution to coat your most difficult products with no touch-up? Then Gama's dynamic contouring equipment is the right solution for you. Unlike robotic coating, dynamic contouring offers greater flexibility without all the programming hassle while correctly positioning each powder gun to automatically coat your parts. For more information, call 877-437-6771. Once again, that's 877-437-6771. And be sure to mention, Ask Joe sent me. When you want to know that everything is covered, complete it with Gama.
Powder Coating Research Group is a proud sponsor of the Ask Joe Powder Powdcast. PCR is the only independent laboratory dedicated to powder coating technology. We do everything from raw material evaluation, formulating the next generation of coatings, new product development, testing, troubleshooting, training, and consulting. To find out more, visit our website at powdercoatingresearch.com, or you can email Kevin Biller at kevinbiller@yahoo.com. Thanks for listening to the Ask Joe Powder Podcast.
There you go. I guess one thing to talk about, because I always talk about gas rather than electric. I want to say electric does work. It is in place, and people are using it effectively. There's kind of a difference that I tried to illustrate here. That with electric, if you see the confines of your emitter are the confines of that emission of the wavelength.
Right. It's very line of sight, like you said on the slides.
Yeah. Whereas with gas, we get a much wider spread of that wavelength, and so it's a little easier to engineer. And I just kind of look, say, yeah, okay, upfront costs on electric is going to be lower, operating costs and gas is going to be better and cheaper. The heat up speed on electric is really fast.
Yeah.
Both will have some degree of convection effect, but gas, because of the consumption of oxygen, naturally is going to create a convection effect. So some people call it softer, right, or whatever. I don't care what you call it. It just is more forgiving.
Yeah.
It's more forgiving. That's the other important part, is that, look, when we look at the CO2 footprint, it really is the responsible choice for non-metal substrates today. We've got, the system is about a third of the CO2 footprint of other incumbent technologies that are out there.
Yeah, and I see your Source DSM there. I know that they've done some really extensive kind of lifetime, what would you call it, cradle to grave?
Yeah, well, they call it life cycle analysis. This one is not cradle to grave. This is from raw material manufacturing to the finished coated part.
Putting it on a part. Okay.
Yeah. Yeah.
It's always interesting to see the comparison there.
Yeah, it's a great, actually, if you just look up DSM life cycle analysis and powder paint, they offer this to everybody publicly free of charge. You can download it. You can use it in presentations. So DSM kind of looked at that as a service to the industry, and I think it was a pretty darn good thing to do.
Oh yeah.
Yeah. You talked about where else could it go. Those were some ideas where we already see it, right? Drywall. I never thought I'd see that, but yeah, it's done quite well. But yeah, man, it's exciting stuff, and I think the future's so bright we got to wear shades. So, but God bless the people who, for the past decades, have continued to bang their head against the wall and try like heck to make this happen.
Oh yeah, there have been a lot of different approaches, and it's cool seeing these actual like really large commercial opportunities coming up.
Mm-hmm. Yeah.
I want to ask more broadly about IFS. Like, do they only produce powder coatings?
Yes, IFS is solely for powder coating.
Which, I mean, that's really interesting because, the traditional model is kind of like giant paint company they end up, buying or creating a powder division to kind of stay in the game. But then it's I don't know. It seems like if you only do powder, then you're going to look at powder-based, solutions for everything. And really push the boundaries a little bit more.
I've had too many fights for that reason, right?
Yeah.
I think back to working with allied suppliers in the context of the Powder Coating Institute and serving on that board, and and my entire thought process is no powder wins, period. Right?
Yeah.
So I don't want to talk about merging with a trade association that does liquid. I don't want to talk about doing a trade show with them, because there's still a lot of room for powder coatings to grow.
I think so. And I think, some of those really, giant companies, and they compete with, internally, they say like, hey, powder guys, stay away from, automotive, like, right. Because we got a good thing going here. Yeah.
Well, it's right in our mission statement at IFS. We want to bring the environmentally responsible choice to market. That's what we're all about. And my background, I was in raw materials for quite a long time before joining IFS, and through all those years, it was always IFS that would launch every new technology I was out there to sell. And so, within the raw material community, boy, in my company, I was a rock star because I'm launching new technologies. Well, I had a secret weapon. I had a company that was big enough to do it, small enough to get it done, and 100% to powder winning.
And willing to to go all in on powder.
Yeah. Well, you think about it. If you're selling liquid paint, right? And I just reminded of a large cabinet manufacturer that I visited a few years ago, and their paint is a bucket of paint. Okay, just picture a bucket of paint. It's 30% solids. Mm-hmm. So 70% of that bucket is going to go off in the air, go through solvent burners, go through people's lungs, everything else, right? Mm-hmm. So that 70% is gone. Now, the 30%, if they're good, if they're really good, they're going to give up maybe 65% of that paint onto the pieces.
Right. General transfer efficiency.
Right. And so we got that much material from that bucket of paint that they actually paid for that is going to be used. And they're selling it $40, $50, $60 a gallon.
Yep.
That's a great business.
Oh, yeah.
I'd be scared of powder, too.
Right.
I'm very happy to say that beyond metal, they need to start being afraid of powder.
Nice.
Yeah. And everybody keeps pushing I mean, right now we're at a place where we can do a lot of stuff: fiberglass doors, gun stocks, all these type of things. But there's still a pretty good push going to get to that 100°C mark.
Mm-hmm.
Get below that boiling temperature. It's been done in the lab, right? But that development. God, I feel sorry for the liquid guys when we hit that number.
Well, and that, as a, lab guy myself, it's like we can make something that'll cure at, as low as you want to, but we can't process it. That's It's because it has to go through an extruder and it has to, see some amount of heat before it's actually a powder.
Yeah.
And that's where the limitation is. Like, okay, we have to melt it once, and then you can't just turn the extruder into a brick.
Well, I wish that I understood how this new chemistry works exactly.
Mm-hmm.
But the IFS is smart enough not to tell me because I'm a sales guy.
Right. Because then we don't know how to do it.
But what we've done is got out of the paradigm where, okay, TG and flow are necessarily related. Mm-hmm. TG and cure are necessarily related, right? Where we can get through an extruder without a whole lot of work, right? And we're not tied to that. What's the guy's name? Is it Arrhenius's law? We're breaking it, right? So I kind of understand conceptually how it works, but
yeah,
I'm always about what it does, not what it is.
And
it really is a breakthrough. Yeah.
But yeah, you compared it to block isocyanate, where we're familiar with that, where it's like, yeah, you can melt and flow it all day long as long as you don't hit that particular unblocking temperature. Then is when all the chemistry happens. But below that temperature, it's all just flowing and nice and smooth. And
yeah, so I always liken it to that because I started off selling urethanes, right?
Mm-hmm.
It's not that. There's an inhibitor that stops everything from happening until 130°C.
Okay.
As soon as you hit it, there's just a big avalanche of reaction.
Mm-hmm.
But, it's a neat trick. And the powders are beautiful. I just got out, with our lab, really faster than anybody else could do it. I think that, was able to come out with a nice commercial product. We're launching cabinet white, right, which is a 25 to 30 gloss white with a PCI smoothness of about 6 or 7, which mm-hmm. is smoother than a thermal foil. We're not quite as smooth as some of these very high solvent born liquid paints. That's really smooth stuff, I have a cabinet front. I took around there's cabinet manufacturers everywhere. I took it to 2 that I know in the Houston area, and both of them said, yeah, we want it. Who can cut it for us?
Yeah. Back to that old question.
I said, yeah, well, I got a guy, but we'll get more. So some forward-thinking contract cutters are deeply in considerations of this now. So I think it's going to go big, and I want to round up all those guys from over the years that believed in this 20 years ago and have a toast for them when it hit. We wouldn't be here without them. So.
Right. So yeah, do you have any cool projects on the horizon you can talk about? Like, is there anything?
Yeah, I mean, one is to do these fiberglass doors that you see in multifamily housing. You see them in every house, right?
Mm-hmm.
6-panel fiberglass doors. So we're dialing in how to get those through the oven, make sure we get the wavelength on all of it. But these guys are quite excited about it. I'm excited about that opportunity.
Mm-hmm.
And there's cabinet fronts, of course, right? And I think it's just kind of cool to say gun stocks, powder coated fiberglass gun.
Sure, yeah.
So those things are cool, and and we're talking to some other folks that are focused in the building and construction side, residential housing, things like cladding as a replacement for something like Tyvek, right? Or there's all these possibilities, and they just keep getting bigger. So,
Awesome.
yeah.
Very cool. So yeah, if people want to find out more about it, about IFS, about
they can email.
Technology.
You can check out our website. It's ifscoatings.com. We've got a section there that kind of explains the technology. If they want to reach out to me, I look forward to conversation. They can email pureclad at ifscoatings.com.
Awesome. I think that's all I have. Unless you got anything else you want to throw out there. But
I'll tell you what, as soon as I got next time I talk to you, I want to be doing a case study and telling you about the person of a big coder. So,
all right, that'd be fantastic. Yeah.
But, thanks a lot. Thanks. Spread that to your dad and tell everybody best regards on that team. So.
All right, cool. Yeah, good talking to you, Chris.
Yeah, Nathan. All right, bud. Take care.
All right. Later.
Thank you for listening to the Ask Joe Powder Powdcast. This episode was brought to you by Gema. Gema's Optiflex Pro manual gun uses Power Boost technology, which gives you the industry's highest charging power at 110,000 volts and 110 microamps, allowing for faster and more efficient powder coating. We're handing you more power, more quality, and more control. For a demonstration, call 877-437-6771. Once again, that's 877-437-6771. And be sure to mention, Ask Joe sent me. When you want to know that everything is covered, complete it with Gema.
You said something about the background, so I had to...
You figured it out?
Yeah, I had to put some dinosaurs behind me.
Yeah, I like it.
Oh my God. I'm really bad at this technology stuff, apparently. See, the thing is, I did another interview a few weeks ago, and it went really great. The whole thing was awesome. And then I went to play the video back, and I had not gotten any of their audio, just mine.
Oh, really?
And the whole thing was just a wash. I was like, God.
Do you want to test that real quickly before we start?
Yeah, let's do that.
Figure that out. I'm sure you can edit out this part.
Oh yeah.